Hi everyone, Jonathan here. I hope you guys are doing great and are having a lovely day. In this video, I'm going to be talking about a tool that is becoming popular among Python programmers, and that is the UV package manager. If you haven't heard of it, it is a package manager that is written in the Rust programming language, and therefore this gives it the ability to be faster compared to tools like pip env and poetry, as well as pip itself. Using UV, you can be in position to use very many other tooling, such as tooling to help you manage your virtual environments, something that you do with virtualenv. You can also be able to do things like managing Python installation, something you do with PyEnv. You can also pretty much do very many other things like reading from environment variables and so on. My goal for this video is to give you a very basic introduction, or basically how I use UV on a daily basis, and I hope you find so much value out of this video. So without wasting your time, let us get right into the video. So to follow along with this video, you're going to first of all visit the documentation, because the documentation will pretty much cover everything I'll not talk about in this video. So it is a source of truth, and you should go ahead and read it to find out more that UV can do. And one thing I'm going to do for the start is to install UV on my system. So I already have UV installed, but I'm just going to be showing you how to install it. Now you have different ways to install UV, including those for macOS and Linux and Windows and other platforms. What I'm interested in is the curl method of installing, because I already have curl installed. But if you do not have it, you can also go ahead and install it on your Mac or Linux machine. So to get started, I'm going to copy this command right here. I'll paste it in my terminal. So what this does is to go ahead and basically fetch the installation script of UV and then execute it within our shell. So it will execute it. After executing it, we shall have a working installation of UV to work with. So since I had this installed, it's going to take a very little time to install. Now, one thing to note here is that we've installed the commands UV and UVX. So UV is the tool that's going to help us to manage our projects, our dependencies, and so on. And then UVX is going to help us to manage those tools that are installed with Python. For example, executables that run directly, that you can run with Python, those that can be installed with a tool such as pipx. So now that we have UV installed, let us go ahead and verify that by running UV. Running UV will bring up this list or this log of the different commands and different subcommands we can run with UV. One of the things we can notice are the command section right here, and the beauty is each command or subcommand to UV is very well documented so that you cannot get lost while using a specific command. One of the commands that I'm interested in for now is going to be the UV Python command, which helps us to manage Python versions and installations on our system. So this makes it easier for us to install Python versions, upgrade Python versions, delete Python versions, and also switching between Python versions, something that you can do with a project or tool such as PyEnv. We also have basically ways to work with pip, so this can allow us to do things like pip install upgrade, and pip freeze, and all the commands that come with pip. We also have the virtual env command or the venv command. So this is very nice if you want to use UV to create your normal virtual environments, activate them, and all that stuff. UV build is going to be to help us to build our packages into things that we can distribute on package indexes, and then we can finally publish using UV publish. Now, I cannot cover all the commands right now, but what I'm interested in is basically how we can use UV. So to start, let us start by looking at how we manage Python versions. If I run UV Python, we can see the different commands, where we have one to list all our available Python installations, install Python installations, upgrade Python installations, find, pin, find out the directory in which a Python installation is installed, and so on. Now, if we run UV Python list, this will show us all available Python installations and those that we can be in position to download with UV. For our case, we have Python 3.13, and this is a managed or Python installation which I've installed via UV. But I also have this specific Python installation that is installed by default using Ubuntu. So on Linux systems, you're always going to have that Python installation, and it's going to be found on USR bin, then the Python installation. So if I run Python 3, that will give me access to the system-wide installation of Python, and I can also verify where it's installed by using the which command. So that will show me where it's installed. But I can also run the managed Python version of UV. So if I go ahead and run Python 3 using UV, notice that I'm going to always provide this command right here to run an executable. So if I do something like UV run, it will list all available executables or all available subcommands I can run directly using Python. So if I go ahead and say UV run Python 3, that will go ahead and show that I'm using the Python 3 of my system. But this does not limit me to using only this Python version. In fact, I can go ahead and switch in between these Python versions using something called pinning. So using the command UV Python pin, we can be in position to show the version that we are currently using, but we can also switch to another Python version. For example, if I wanted to switch to the system-wide installation, I can use UV Python 3.12 or UV Python pin and then the version number for that specific Python installation I want to switch to. So running that will go ahead and update this file called the .python version. Now, I'm not really sure whether this is installed, but I'll maybe try to find out. So if I try to locate it, we're now going to see that it's located inside the home folder, inside the .python version file, which is a hidden file. So I can go ahead and copy it and then maybe cut that. So that's the command to read from a file and print to standard output. So that will go ahead and basically show us that we're using Python 3.12. And if we switch back to Python 3.13, that will show us that we are now updating this file and we have switched from the file or the Python installation we set to Python 3.13. So this is basically allowing us to do something we would do with PyEnv, which is basically have different Python versions, manage .python versions, but also switch in between those Python versions to work with them. This is very useful in case you have situations which may require you to use different Python versions for different projects. So that's basically how we do it. And if we run UV run this time, we get back to our Python 3.13. So what would happen if I switch back to Python 3.12 and run UV run? This time, I can see that I have other commands I can execute with UV run. Now, these commands are basically system-wide specific commands that I can execute via UV. So, yeah, that's basically it. I can switch in between my Python for the system and the Python for our UV. So if I do UV run Python 3, this time I expect to use my system-wide installation of Python. And that is very useful because I can determine what I'm using for a project and I can switch to another Python version. So I'm going to exit out of this. And once I've done that, the next thing we can maybe look at is how to basically we can look at some of the sub commands. So if I did UV Python list -- help, we can see different sub commands right here, like listing all the versions of Python I have on the system, listing versions for all platforms. So if you have different platforms, you can go ahead and list using all platforms. You can also show only downloads, so those that have been downloaded will be shown. If you have only installed versions, we shall list those. So if you come right here and say UV Python list and then specify that we only want only installed versions, so that will list only ones that are installed. And if we do only downloads, that will show only those that are available for downloads. So that is very important in case you need to install your Python packages. So we can go ahead and remove Python installations by running UV Python remove, and then we specify the version number for that specific Python installation. We can do 3.12 or 3.13 and enter, and that will be in position to help us to remove a Python installation. So UV provides for us very easy ways to manage our Python installations on our system, and this is basically one thing it does that basically makes it use existing Python tools like PyEnv. With this kind of setup, we can be able to do quite a lot without having to do anything. So yeah, let's go ahead and now set up a simple project using UV. So to start doing that, I'm going to create a simple folder in here. Let me call this folder UV demo. I can also open up VS Code within that folder. And this is exactly where I'm going to work, but I've opened this up inside the home folder, I think. So I'll close that. I'll have to cd into the file, or actually the directory, and then I open up my VS Code. So once I open up VS Code, I have an empty folder for now. So I'm going to be switching in between my terminal and the command line. So one thing to note is I have an empty folder for now, and even if I ls here, there is nothing that I currently have. But if I wanted to create a fresh UV project from scratch, the command to do that is UV init. If I do UV init -- help, I can be in position to see different things I would provide as options. So this basically takes in the path where I want to create the Python project or the script, and it also takes in the various options like the name, if I want to create it with the project.toml file, which I'm going to be describing later. If I want to create this as a package or not a package, if I want to create the project for an application or a library, then it provides all those specific commands or basically options that you can provide. So if we run UV init, I maybe specify the folder source. We now see that a fresh folder here called source is going to be created within our directory. And if I run tree, we now see that this is going to have main.py, pyproject.toml, and readme.md. So these are the only files that are located inside that project folder. Once I have that, I can then go to VS Code to show how these work. So we just basically have a folder inside our root project folder because we specified it when creating the project with UV. But in case we want to create all these without the folder, I can delete the folder here, and then I can go ahead and recreate that without the folder. So I can say UV init, and that will go ahead and simply provide for us the main.py file, which is the script or the main project file, the pyproject.toml, and the readme.md. So those are the three files that we have created for our simple UV project. Now let's go ahead and look at what each of these files are. If we go to our VS Code right here, I'll notice that we have other files that have been added, and those are the gitignore file, which contains some defaults for Python specific things we do not want to add to source control. We also have a virtual, we actually have a Git repository created for us. So if we do something like git status, we now see the different files that we haven't added to source control. So this will create the project, initialize a new repository, and then allow us to work with that. So gitignore is going to have those Python defaults that we do not want to add to our virtual environments. We also have Python versions. So this will default to what we set, which is our UV Python pin. So We set our version to Python 3.12, so when you create a project, it will be created with that, but we can switch and make it different. So for example, if I set this to Python 3.13, that will be the specific version of Python that we shall use for this project. Now let us move to our main project file, which is main.py. Inside here is where we can write some code, and when we write that code, we can go ahead and execute that code using our UV. So pyproject.toml is the file in which we can go ahead and define the metadata as well as the dependencies for our project. But it is more than just that, because inside here is where you can write the different scripts or set up different things for different Python packages instead of writing different configuration files for those packages. I think I'll make a separate video showing how to set up things like PyTest using this pyproject.toml file. It is very important and there's so much you can do with it. But for now, I'll just show you how to manage dependencies. So one thing to note here is that we have this project section right here. So in a toml file, we basically have this syntax of key and value. Each key is going to identify an attribute and each value will be the value for that specific attribute. So for example, we are having our name, and that name is the name of the project we provide, which always defaults to the name of the folder we provided right here. So we can change this and make it something like UV for beginners or something like that. So we can also provide the project version depending on how we are versioning our project. Then a simple description for the project. So I can go ahead and add it here or edit it. Once that is done, we have the readme.md attribute that points to the readme.md file, which will contain a description about our project. Then the next thing is requires Python. So this is where we actually point to the specific version of Python we want to use. So this syntax basically means we want to use any version of Python that is greater than 3.12 or greater than or equal to 3.12, which means we can also change this to be 3.13 or 3.14 or whatever version of Python we want to use for this project. So the dependencies list is empty for now, but this is where all the dependencies for our project are going to be added, and UV will automatically add these without us having to specify them. We can also specify them and use another command that I'll talk about later to go ahead and set up a virtual environment and install all those packages without us having to use UV to install them. But I'm going to be showing that in a moment. So once I've looked at the project folder, let us try to add some packages. I'll pull up my terminal, and since I have everything right here, I can install packages using UV add. So if I go ahead and pull up the help section or pull up the docs for that, I'll then see the different options that I have to provide. So there are quite many, but what we have here is you provide UV add, and then you provide the options, and you provide the packages you want to install or requirements. So if you wanted to install like fast API, what you can do is to say UV add fast API, and then maybe we can do a standard installation in here. Now this is what makes UV interesting. UV, instead of downloading each package one by one, will parallelize, I don't know how to say it correctly, but what it will do is to split all these into chunks or download individual packages all at the same time, enabling us to fetch packages faster compared to tools like pip. So if I did UV install fast API standard and maybe Ruff, we can now see not a valid package name, UV for beginners, names must start or end with letter, a digit, must only contain that underscore or that. So I guess the spaces are not allowed, so that is my mistake. So if I go back to my project.toml, I'm going to change this to UV for beginners. Sorry for my mistake. And if I go back here and try to install, if my PyProject.toml exists, we now see our packages installed. Now, there are two things that make UV a little bit faster. Notice how these packages are installed individually and all happening at the same time. This is something that pip does not do well. For pip to install packages, it has to fetch an individual package one by one, but this one kind of does it in a concurrent way, where it will fetch all packages at the same time, allowing for speed, or basically packages being fetched fast. So now we've installed 42 packages and very many, which are very many right here, and we basically installed them and resolved them in the shortest amount of time. To verify that, we can go back to our pyproject.toml. So the pyproject.toml file will automatically add those under the dependencies list right here, where we can see our Fast API standard installed and our Ruff installed. So one thing we can also note is that a new file is created right here. So this new file is called the uv.log file. It is a really weird file, or a long file, but what it does is to basically add all specific versions for the project dependencies we've installed, plus all the sub dependencies, as well as metadata to allow us to install those dependencies. So if someone is starting from scratch and they are basically working with our project, they'll need just one command to go ahead and fetch all the packages with their exact versions, thanks to this file right here. So it will have all packages, all tools, and everything we've installed that the pyproject.toml file has just summarized right here. So Fast API standard will have its dependencies, but then we'll have sub dependencies, and Ruff will have dependencies and sub dependencies. But for us to keep exact versions of those dependencies and sub dependencies, the UV log file will just keep track of those, so we do not have to worry about those. I'm going to close that file for now. And another interesting command we can run in our environment with UV is the UV tree command. So what this will do is to go ahead and basically list all packages like Fast API standard, and then it will go ahead and show all the sub dependencies of those packages like Pydantic, Starlet, typing extensions, Fast API CLI, and all the rest. But it will go ahead and also list the sub dependencies like annotated types, blah blah blah, any IO, blah blah blah, for that specific sub dependency, which is kind of useful and it's very interesting. So yeah, that's basically how we can manage our packages using UV. We can also remove packages by basically using UV remove and then the package name. So for example, if we wanted to remove Ruff, we can go ahead and say UV remove Ruff and then press enter. So that will be very fast to go ahead and remove UV plus all its dependencies. So if I go back to my PyProject.toml, we see that that is automatically removed here, and our uv.log file will also be updated to remove the Ruff formatter or linter. So if I search for Ruff in here, we cannot find it because it has been automatically removed. So this file right here plus the pyproject.toml file are very important for dependency resolution. UV will just check in here for all the dependencies and then basically install them, or install the exact dependency versions for those specific dependencies. Now that we've looked at how to install and remove packages, the next thing we're going to do is to try to write some code and see how we can run it with UV. Remember, we created a file in here called main.py, which is like the only Python file inside our project. But we can expand on this to have things like packages and files, and where we can enter or create entry points to different directories and files and expand the file structure or the folder structure. So for now, we can only work with this file. If we wanted to work with it, we can basically go in here. Since we have Fast API installed, I can point to that specific virtual environment in VS Code so that I can enjoy things like auto completion. So I'm going to exit out of that, and let's create a simple Fast API server. I'll import the Fast API class. World. So once we've created our code or written our code in a file like this, or we have a project folder that has some code like this, we can use UV to run that code thanks to the UV run command. So I've shown you the UV run command that allows us to run executables and run files. So if we had a script like, let's say, the main.py, we can run it directly by running main.py. So that will go ahead and run that file. And since we do not have any ways to run that, we can simply go ahead and just directly run it. But we do not have anything to make that server run. So we can use something like UVCon, where we can say import UVCon. This time, we are going to see that this is a coroutine. So server.serve was never awaited. I think this is run in a coroutine of some sort. So I'm not really sure how this works. Maybe I've forgotten how it works, but I'll need some help in the comments. But yeah, that's basically the basic idea of how you can run a script. You can just directly call UV run to run that script. But what if you wanted to use a CLI to run that script? So to run a CLI, you can do something like UV run and then specify the command you want to run. Now, since we have the Fast API CLI, I can run UV run, and that will show us that we need to provide a command. So if I run UV run Fast API -- help, that will give us access to the different commands that we can run on our Fast API app. So if I run UV Fast API dev and then point it to main.py, that will go ahead and run our server, but we now see that the port we are trying to use is already in use. So can specify a port using the -- port option, and then I'll provide 8003. So that will make our server run on localhost 8003. So if I go ahead and access that, we now have a simple API server running on that specific address. So yeah, that's basically how you run command via the CLI. If you have access to tools like Ruff, let me go ahead and actually re-add it to our project. So notice how fast that was. That was fast because Ruff will, UV will go ahead and cache, or basically keep these dependencies in a cache, so that if we are reinstalling them, they do not take time to reinstall. So yeah, that's one added thing to increase the speed at which we install packages. So now that we have UV installed, Ruff installed, we can go ahead and do something like UV run, and then we shall see the Ruff command is back. So we can run UV to maybe lint or format our file. So if I run Ruff check dot, we now see all checks passed. So that means we can proceed and there is no errors in our code. If we run UV run Ruff and maybe format, I think this time it will format the main.py file to a specific standard. So yeah, that's how you can execute commands using UV run within your project. So at this point, we've been able to explore how to use UV with a fresh Python project. And that is very helpful in case you're starting a new project. But what are scenarios in which we have a new project, but this is uninstalled, or this is an existing Python project that's already using UV? So that's exactly what I'm going to be talking about. Working with existing Python projects that use Ruff is a very simple thing. To do that, we first of all are going to edit our project to make it seem like something we've cloned from GitHub. So I'm going to remove some of the generated stuff like this folder, the Ruff cache, the venv, which is our virtual environment. I'm going to go ahead and remove them. So basically a Python project you've downloaded from, let's say, GitHub or somewhere, is going to just basically have the following. It will have the pyproject.toml file, which will contain a list of the dependencies as well as metadata for the project. It will have the Python version file for the specific version that the project uses, which Ruff will then go ahead and fetch or download. Then it will have the UV log file, which is very important because the exact dependencies or exact versions of dependencies and sub-dependencies will be found in there, such that on whatever platform a user is using, they'll be in position to install the project as it was initially built. So UV provides some commands that are very important when working with existing Python or existing UV projects. So in this case, when you get a project like this, the command you're going to be running is UV sync. And what this command will do is to first of all create the virtual environment if you do not have one created. It will read through the Python version file here to go ahead and install that specific version of Python that you've installed, as well as to install all dependencies that you specify when this file is created, the uv.log file. So if you run UV sync, this will go ahead and fetch or use our catch to just go ahead and add all installed Python packages. So all these Python packages that are detailed inside our uv.log and are listed inside our pyproject.toml file will then be fetched, and the virtual environment will be created right here if it doesn't exist. So that is the importance of that UV sync command. It is just a command that will be just important in helping you to set everything up from scratch. You'll get the virtual environment created, the project dependencies set up, and even if the uv.log file does not exist, it will go ahead and create it for you or add it for you with all the dependencies. We also have the uv.log file or uvlog command, which is necessary to help you pin exact dependencies of the dependencies you're using, or I'm actually meaning the exact versions of the dependencies you're using within your project, so that when people who are going to work with your project are using your project, they can be able to install them thanks to the uv.log file. So if I run uvlog, that will go ahead and basically resolve all the packages for the system and then update this file right here. So in case you want to upgrade the packages that are found inside our pyproject.toml, you can also run uv sync -- upgrade to go ahead and basically upgrade all those packages. And since they are the latest versions, this will take a very short amount of time to install. Now that I've shown you that, let us go ahead and look at how we can work with versions or work with virtual environments when using UV. So this has assumed that this project was not created with UV, but was created with virtual environments. So one thing I'm going to do is to get rid of all the stuff that we have in here that is created by UV, including the uv.log, the pyproject.toml, the Python version, as well as the venv folder. So I think I deleted or accidentally deleted the file main.py. So let me try to undo, and here's our main.py, which I actually need. So I'm going to keep what is necessary and get rid of what is to be left. So I'll delete the virtual environment, the Ruff cache, and the Py cache. And then I'll delete the uv.log, the readme.md, pyproject.toml, and the Python version. So when I delete those files, in most cases, our project we are starting with the virtual environment is going to be one that is going to have some sort of like requirements or txt file. So this is how you can move projects that you've already worked on that use the requirements or txt file as a way to install packages. You can basically have, let's say, Fast API standard as well as Ruff as your packages. So if you got a project that has only the requirements.txt file and the code, then this workflow with UV is going to be very helpful. You can begin by first of all create the virtual environment. So UV venv, if I go back to my terminal right here and run UV venv, that will show us basically a command to create our virtual environment. If we do not specify a name for it, it's going to be called .venv. But if we, let's say, remove it, and let's say rerun the same command but with the name of our virtual environment, this time we shall see that our virtual environment will be created as a folder env. We can also activate that by running source env bin activate. So what that will do is to go ahead and activate our virtual environment, and that will be the virtual environment with the same Python that we installed within our, or the one that we actually set up or pinned with our UV. So if we run which Python 3, that will be our Python 3 within our virtual environment. And if we did something like Python 3, we shall see that we're using Python 3.12, which is our pinned Python version. So if I did UV Python pin, that will be the version that we pinned. So now that we've been able to create our virtual environment with activating it, let's go ahead and install the packages that are present within our requirements.txt. So we can be in position to use pip with UV using UV pip. So if I go ahead and run UV pip help, we shall see all the pip commands are basically available on our UV pip. So you can do things like UV pip install -r requirements.txt, and that will go ahead and fetch all the packages. Now note that still we have the same speed at which we install dependencies when using a direct UV project. So this comes with advantages because we can install all these requirements without having to wait for a long time. So since it keeps a cache of all these dependencies, running UV pip will install packages faster compared to running pip directly. So we shall have all our dependencies installed right here. And then you can go ahead and run your file or run your packages. So in this case, if I run UV run, I'll still have access to all the commands like I had for our UV project. So this is how you can install UV or introduce UV to an existing Python project that uses virtual environments with pip. So you can run UV run fast API run, and then the name of the file, and then maybe can provide the port. So can provide the port as port 8003, and that will go ahead and run our file. So yeah, that has been everything that I could show right now. So UV is a very amazing tool, and I'm actually creating all my videos from now on with this package, and I'll be rewriting some of the courses and some of the tutorials I've been making to make use of UV as the main package manager, because it provides quite a lot of functionality out of the box and help us to manage our projects without having to install extra dependencies. So it's such an amazing tool. In this video, we've been able to look at UV. I've introduced UV, have shown you how to use UV for Python package management, installation management, and the rest. I've also shown you how you can introduce UV to your existing Python projects that use either UV or normal virtual environments. If you've enjoyed this video, please leave a like, click the like button. It helps the video so much. And please subscribe to the channel if you found my content helpful. I will be making it a point to upload every week, and that's exactly what I'm doing currently. Thanks for watching, guys, and I hope to see you in the next video. Peace.